Continuing with section 6.3, we're going to look at the nearest neighbor algorithm. Again, this algorithm will not necessarily give you the best answer, but it will give you an approximately good answer. It will never give you the worst answer, but it is significantly faster than the brute force method. So what we're going to do is start at some vertex and look around and see which of the vertices is closest to the vertex we are. By closest, I mean it has the smallest weighted edge. And then from there, we go on to the next vertex, and we look around and see where we haven't been and see which edge has the lowest weight. And then that's where we go to the next vertex. And then we're going to continue that, not completing a circuit until we've been everywhere. And then our last step is to complete the circuit. So we're going to start with our vertices. And let's say that we start at A. Get rid of that extra little line there. Alright, so if we start at A, we look and we have 13, we have 11, we have 15, and 17. 11 is the smallest, so we go from A to C. Weight of 11. Now we're sitting at C. We have an option of going to B, E, or D. B is 20, E is 14, D is 12. So from C, we want to go to D, which has a weight of 12. We're now sitting at D. Our options are to go to E or B. If we go to E, that's 16, B is 19. So we go to E, which is 16. We're at E, so we don't have a choice where we can go. We have to go to B, and E to B is 18. And then now we've been everywhere, we want to close the circuit by going back to A, which is 13. So our circuit is A, C, D, E, B, A. And you find the weight of that circuit by adding the edges together. So again, I'm going to start this one at A. So this is A, B, C, D, E. So if we start at A, we have 4, 2, and 3. 2 is the smallest, so we go to C. I'm at C. I could go to B for 8. I could go to D for 1, and there's no way to go to E. So the smallest is to go C to D for 1. I'm at D. My choices are B and E. D to B is 5. D to E is 2. So I choose to go to E. I'm at E. I don't have a choice. I want to go to B for 4. And then I want to close the circuit B back to A for another 4. So that circuit is A, C, D, E, B, A. Then you find the total just by adding those together. 4 and 4 and 2 is 10, so the total there is 13, which is the same thing we got when we were using the brute force method. But let's reconsider this and start with B and see what happens. So if we start with vertex B instead of A, let's find out what happens. So if we start at vertex B, we have a choice of 4, 4, 5, and 8. Well, that's a bad choice. Let's see. How about if we start with C? If we start at C, we have a choice of 8, 2, and 1. So C, we would want to go to D for 1. If we're at D, We look around and we have 5 and we have 2. So E is our best choice. We're at E. We haven't been to B or A. B is 4, A is 3. So we go to A for 3. So now we're at A. The only place we haven't been is B, so we go to B for a weight of 4. And then close the circuit by going back to C. So that circuit just goes around the outside. So 8 and 2 is 10, 18 total. So notice, if we start at 2 different vertices, nearest neighbor sometimes will give us 2 different answers. So you need to be careful with nearest neighbor to start with the vertex that they ask you to start with. Otherwise, if you start at a different vertex, you may create a different circuit than the one that you should be creating.